the walls of the world's museums lies much of what we know about the history of life on Earth. Chicago's Field Museum of Natural History is one of the largest. It holds over 24 million specimens and counting. Among them, some of the greatest dinosaurs ever found. Dinosaurs were the largest animals to ever walk the Earth. They first appeared 245 million years ago and evolved into amazing shapes and sizes. And though their ancestors were small, many became giants. Among the most ferocious of the dinosaur giants was Tyrannosaurus rex, a meat-eating predator that was unrivaled in the dinosaur kingdom. And this is the grandest of them all. 40.5 feet long, 13 feet tall, weighing 7 tons in life. And its name is Sue. Its 5-foot skull weighs 600 pounds. Its jaws hold 58 sharp, curved teeth, some 12 inches long. Sue has been waiting 67 million years for this moment. This is Sue's story. 67 million years ago, no animal was safe from a T-Rex attack. Edmontosaurus dinosaurs could reach 40 feet long and weigh 4 tons. Their duck-like bills and rows of grinding teeth were built for eating plants, not fighting predators. But fossil evidence suggests Edmontosaurus was a common T-Rex meal. Tyrannosaurus rex means tyrant lizard king. It possessed the most powerful bite of any dinosaur. When T-Rex lived in the late Cretaceous, parts of the American West looked like this: a subtropical floodplain and home to dozens of species of dinosaurs. But over time, the climate changed, and much of it became this semi-arid land we know today. Dinosaurs that died long ago were buried within the earth. Their fossilized remains eventually thrust upward as mountains were formed, their bones becoming exposed through millions of years of erosion. It is within this constantly eroding landscape that scientists seek to find new dinosaurs. At an area of uplifted rock called the San Rafael Swell in Utah, paleontologist Lindsay Zano explains how they hunt.
Well, finding fossils is a relatively simple process. It hasn't changed in hundreds of years. We find rocks of the right age. We get a team together. We come out and scour the hills looking for bone that's eroding out of the hillside. When we find bone in the fields, it's found in these little chunks. And what's interesting about the bone, how you can distinguish it from the rock, is that it preserves its original texture. You can still see evidence of the cells and the nerves and blood vessels that used to run through the bone. can be extremely tedious, but it's not as difficult as preparation back in the lab. So for every hour we spend excavating a dinosaur, they might spend 100 hours at the lab getting that same bone to the final state it will need to be in before it can be researched.
Bill Simpson is part of the excavation team.
We think we found the backbone from a dinosaur, a carnivorous dinosaur. We think this is from the tail. We have a number of bones from this animal. It's an animal that would have been a little bit smaller than T-Rex, but recognizable as an animal similar to that. So what we're going to do is put burlap now around it, maybe some surgical bandages and plaster, and make what we call a field jacket. And once the plaster hardens, it's basically a carrying case.
Ready? 1, 2, 3, go.
And we'll take them back to the museum where our skilled preparators will open them up in the laboratory and figure out just what this animal is like.
I think it's the love of adventure and discovery that draws people into paleontology, and just being outside, getting to spend a lot of time traipsing around really remote places and being the first person to see something for the first time in 100 million years or something like this. It usually gives us a pretty big thrill.
At dig sites like this, a great new discovery can happen at any time. Like one did on a hot summer's day in 1990. Dinosaur hunters from the Black Hills Institute of Geological Research are searching for fossils in the badlands of South Dakota. One of them, Sue Hendrickson, and her four-legged companion Gypsy, come upon several large bones protruding from the side of a hill. The group soon realizes that Sue has found something extraordinary, a huge T-Rex. It takes 2 hard weeks to excavate this massive creature from the hillside. The plaster jacket encasing just the skull and hips weighs 4 tons. And though they don't know if it's a boy or a girl, the team decides to name this T-Rex Sue, in honor of the Sioux who found it. Back at the Field Museum, one of the plaster jackets collected in Utah is about to be opened. The process is sort of like cutting the cast off someone's broken leg.
It's open.
It isn't until all of the surrounding rock matrix is removed that they will know exactly what they found. This is the same process that brought Sue back into view after 67 million years. It took 12 preparators nearly 2 years to fully free Sue from her stony grave and reassemble her. Fewer than 40 T-Rexes have been found, but only partial skeletons. Sue is the most intact T-Rex discovered to date, now standing 90% complete. Imagine what it must have been like being Sue. Female tyrannosaurs may have laid as many as 40 2-foot-long eggs. Their number and size is uncertain because no T-Rex egg fossils have yet been found. Baby T. rex Sue and the rest of this clutch are at risk, even before they hatch. A Paleociniwa lizard, related to monitor lizards today, feeds on eggs and small animals, including young dinosaurs. It smells the nest and moves in. A hoped-for meal becomes a brush with death. This lucky lizard will live to see another day. In her first year, young Sue may have been covered with downy feathers, something we know T-Rex ancestors had. Feathers help regulate her body temperature. As she grows larger, she will shed them. Sue can run soon after hatching and has a jaw full of functioning teeth. But in her early years, she is vulnerable to predators and stays close to mom. At age 7, Sue weighs less than a ton, and her coat of fuzzy feathers is getting smaller. Sue may eventually have become a solitary animal, living and hunting alone. In the years since Sue's discovery, scientists continue to learn more about her from her bones. Complete casts of her skeleton, like this skull, are studied and exhibited around the world. Because Sue's skull was so complete, researchers were anxious to look inside before the rock was removed. Packed in a protective crate, it was probed by an imaging device that Boeing uses to examine space shuttle parts, called a CT scanner. The CT scans gave scientists unique views inside Sue's head, without damaging any of the fossilized bone. Bill Simpson explains.
CT scanning is basically an X-ray process, but instead of an X-ray showing all of the bone at once, it's as though you were taking a butter knife and slicing a stick of butter into slices. And then the computer can put together all these X-ray slices into a three-dimensional object, and it allows you to look inside the skull in 3 dimensions. What we're looking at here, here's the right lower jaw. Look at all these huge, very thick teeth. They could bite through not only soft tissue flesh, they could bite through bone, which for me makes the Tyrannosaur the most interesting of the carnivores. It could have bitten through anything it could find.
Sue had a great sense of smell, and her large eyes, set far apart, enabled her to see at 7 miles what we can see at 1. This combination of well-developed senses and a big bite made T-Rex the top carnivore of its era. Some clues to Sue's life can be found by looking inside her bones. Paper-thin cross-sections of bone are cut, polished, and mounted on a microscope slide. Peter Makovicki, curator of dinosaurs, then examines the cellular structures within Sue's bone to determine how fast or slow she grew.
The most prominent feature that you see is growth lines in the bone. So much like you would see growth lines in a tree, Sue, other dinosaurs, and many reptiles today actually have periods of the year where their growth stops and it leaves a ring or a line in the bone. And so if you look behind me, there's a number of growth lines here. So this marks Sue's 15th year. This one is the 16th, the 17th, the 18th. Here's the 19th. And the last 9 years between age 19 and 28 are actually packed into this outermost layer of the bone. So this really tells us that at age 19 she had reached her full size. She basically didn't change in size over the last 9 years of her growth.
The outside of Sue's bones also tells us much about her life.
One of the great aspects of having a skeleton as complete as Sue is that you really get a picture of the life that this animal lived. And Sue, it turns out, has lived quite a hard life. She was afflicted by a number of diseases that left marks on her skeleton. She has a number of holes in her lower jaw that are possibly due to an infection. A number of her ribs on both sides have been broken and rehealed. She has a large infective lesion on one of her legs. And she's also showing signs of aging in that a number of her tail vertebrae show clear signs of arthritis.
The arthritis wasn't fatal, and Sue's bone damage appears to have healed, which tells us she did not die from these injuries. From age 13 through 17, Sue is going through a massive growth spurt, like teenagers do. She is putting on up to 1,600 pounds per year, and no doubt has an enormous appetite. At nearly 30 feet long and weighing up to 10 tons, Triceratops is a formidable creature. But to Tyrannosaurus Sue, it's just another meal. Triceratops' large bony frill and horns probably evolved to attract mates and convey dominance, but could also be used in defense. And though Sue is the fiercest predator in the neighborhood, a misstep could result in a fatal goring from Triceratops' massive horns. Sue's serrated teeth are like oversized steak knives. And T-Rex teeth grew throughout their lives. Rather than risk injury in a prolonged fight, after an initial attack, Sue backs off to wait for her prey to die, like sharks are known to do. Without any chewing teeth, Sue swallows flesh and bones whole, snatching up to 100 pounds in each giant bite. By age 19, Sue is fully grown and weighs 7 tons. She limps a bit from her infected leg, and arthritis has slowed her down. But she's still the king or queen of beasts. Sometimes Sue's meals are accidental. A pack of hungry troodons is feasting on a carcass. Troodon means tooth that wounds, and these 6-foot, 100-pound bird-like raptors are aggressive meat eaters. Sue moves in to claim this buffet as her own. She's still an effective predator, but it takes less energy and less risk of injury to scavenge for food instead of fighting for it. For millions of years, dinosaurs lived and died, usually leaving little evidence of how they perished. We don't know how Sue died at age 28, but she lived a full life, surviving both injury and disease. Because so much of Sue's skeleton was found intact, she was probably covered by sediment soon after death, keeping her remains from being scattered by predators. Over time, the pores within Sue's bones and some of the bone itself was replaced by minerals, hardening them into fossils. Entombed in her mudstone grave over the ages, erosion finally freed her so she could tell us her story. This Tyrannosaurus rex named Sue, one of the true giants from the age of dinosaurs, died 67 million years ago, but has returned.
Sue is like the Rosetta Stone for this species. Sue gets studied every year by visiting scientists, and millions of visitors have seen her at the museum.
With time, as new techniques for investigating specimens scientifically, new technology becomes available, we're going to learn a lot more.
T-Rex was without a doubt a superstar of the dinosaur kingdom. A creature that evolved to become perhaps the greatest predator the Earth has ever known. That dinosaurs as awesome as T-Rex once walked this planet will never cease to fascinate us. That Sue's bones continue to reveal new insights about her life is a gift for all time.